Hey guys, this is Coach Brian. I'm going over the ReTeach. We're going to do these throughout the year. It's just like short mini teaching lessons and series over things that are really key for us to know that we've identified that we need extra help on. So this first one is all about parallel and perpendicular lines, which we studied very recently, and it's specifically focused on using the different equations of a line and using parallel and perpendicular slopes. So I'm just going to jump right in because I want this to be fast. When you are completing one of these equations or one of these word problems, like the example we're going to do down here, the first thing you have to do is to find the slope. And you know that you have the slope whenever you get whatever your starting equation was into y equals form. Now, usually there's a number and there's an x, and sometimes you might have your y-intercept, but this m represents your slope. So when you get to that point where your y is isolated and your m, the number in front of your x, is representing your slope, you know that you have that line's slope. Second thing, when you're finding a parallel line, okay, sometimes the problem says find the parallel line. You will know that you have the parallel line because they have the same slope. It's going to be the exact same identical slope. Perpendicular lines have a slope that is the negative reciprocal. And what that means is you are finding the inverse and you're changing the sign. So for instance, if I had a slope of 4 over 3, I would flip the slope and flip the sign. Those two lines with these two slopes, are perpendicular. Then I would use the point slope equation. If you don't remember that, it's what we use when we have a point, all right, at least one, and we know our slope, but we don't know our y-intercept. And we use this form, okay, to get our equation into slope-intercept form. And that's what we're trying to get into, is slope-intercept form, which is y equals mx plus b. So again, just for the sake of speed, if you need to slow this down or go back or review anything, feel free to. We're going to work through a problem together. It says find the equation for a line that is parallel and perpendicular. So we're finding both, and we know for sure parallel is going to have the same slope and perpendicular is going to have the negative reciprocal. And here's our original line, and here's a point. So we have a lot of useful information here. The first thing, if I go back up to my steps here, is I have to get this original equation into slope-intercept form. And so right now, 6x plus 3y equals 15 is in standard form, and I want to get the y isolated. So the first thing I'm going to do is move over the 6x. All right, I'm going to move over the 6x. And since those are unlike terms, I'm just going to have a negative 6x, and I still have my positive 15 that I started with. I'm still trying to isolate the y, and so I also have to get rid of this 3. And when I divide that by 3, I also have to divide every other figure in the equation by 3. So that leaves my y isolated, and negative 6 over 3 is negative 2, and 15 over 3 is 5. So it says write the equation and solve for y. That's what we just did. So our slope-intercept form of the original equation is y equals negative 2x plus 5. And the slope is negative 2. Another way you could write it is negative 2 over 1 because it helps you with the rise over run if you're graphing this. Now, Like we said earlier, the slope for the parallel line is going to be the same. You cannot record a video in this school without the bell going off. So the slope for the parallel line is going to be the same, and that means it's also going to be -2. And then the slope for the perpendicular is going to be your negative reciprocal. That means I'm going to take this and -2/1. I'm going to flip it, and I'm going to change the sign. So it is +1/2. Now, I do have this point, okay? I have this point that it goes through. It says 5, -3. They both go through 5, -3. And now I know their slopes, -2 and +1/2. Excuse me. So now I'm going to use point slope form, and that is going to be y minus y1, so y minus -3 equals my slope, -2, times x minus x1, x minus 5. Now, if you remember from class, our goal for point slope form is to get a line into slope intercept form. And so first thing I'm going to do is I'm going to get these signs straight. Subtracting a negative is the same thing as adding. And on this side, I'm going to distribute. And as I distribute, you can kind of see it start looking like slope intercept form. And so the last thing I need to do to fully isolate this y is move the 3 over. And so I've got y equals -2x. 10 minus 3 is still +7. So that is my final slope intercept form for a parallel line. And we'll do the exact same process for a perpendicular line. We have x1 and y1. We have our slope. And do y minus -3 equals 1/2 times x minus 5. Same thing, I got to get my signs straight. So that's a y plus 3. On this side, I'm going to distribute. So that's a 1/2 x. And then -5 over 2. -5 over 2 when I multiply that out. And the very last thing I'm going to do is subtract 3. Now, when I subtract 3 from this, it's, 3 is a whole number, 3/1 minus 5/2. So one thing that would be helpful is go ahead and make that -3 a fraction over 2. So that'd be -6/2. And so my final form would be y equals 1/2 x minus 11/2. All right, hopefully that helps refresh your memory a little bit on slope, parallel slope, perpendicular slope, slope intercept, point slope, and